Hi folks, today I'm very pleased to be interviewing Sudiip Mathur of Genisys Robotics about the breakthrough in artificial intelligence these days. I used to work myself in AI in the 80s and I'm very interested to learn from Sudiip how far AI has come and specifically what I can do with AI now as a human, for personal use, as well as for business cases. So we've mapped out a few points here that we want to cover, and I'll say briefly for people, this assumes that you haven't got much knowledge about AI and you're just starting out, but AI is the way of automating human thought so that you don't have to spend hours and hours going through a lot of data. The AI can come back with very useful information for you, and then you can do what you want with that information. So that's the idea. It's Sudeep is from Genisys Robotics, and he's got a company that provides various modules in AI that can be applied to all kinds of data, and I'll be very interested to hear those, and you will be able to use those as well. They're available online. In short, I won't go on too long, but in short, AI is to do with pattern recognition. It's getting the valuable data out that would take you hours or days or even years to get that valuable deduction from the data. That's what AI is doing today, and it's being widely used a lot behind the scenes, but now it's starting to become democratized so that ordinary people may be able to use it in their daily lives. I'm not sure how much. Sudeep will be able to tell us more about that. Okay. Sudeep, tell me a bit about what AI can do these days.
Well, thanks, Bruce. Thanks for introducing me, and thank you for giving me opportunity to talk about AI. Yes, I am also a learner of AI, as much as a practitioner of AI. The idea behind AI is we have got into this, that from the 80s or maybe the 50s when we started to think about the machines who can think, and the way we started to think about machines who can think are the machines that can actually think like humans, behave like humans, have emotions like humans, have capabilities like humans. And then a lot of thought went into the physical body of it. So if you look at the movies and the folklore, and the kind of books that were written in the 50s
Yeah.
and 60s, when you were trying to imagine a human-like or a superhuman intelligence, it was more
Right.
always embodied with a
Right.
physical body. You think about the Terminators, or you think about HAL, you think about all of these things which were the artificial intelligence.
Yeah.
Artificial intelligence today, and this is where sometimes I cringe at the word artificial, is because artificial means that it is something outside of you, something it is alien to you. I tend to use the word AI more in the terms of augmentation of intelligence, or
Mm.
augmentation of individual, or augmentation of the industry. Industry, which is a collection of people, is what I coming together for a purpose. So
Yeah.
that's where I try to call AI, and that's where I think that AI has a potential to make a vast difference to anybody and everybody's life.
Right. So just
Is
I'll stop you there. Just the artificial intelligence is no more artificial than a spreadsheet or a word processing program. It's
Yes,
just a tool of software. And
yes,
and as you were saying, it's not about trying to fully replicate what a human being can do any more than a
yes,
spreadsheet does. So a spreadsheet's very useful to us, but it's nowhere near as clever in deduction and wisdom as a human being. But a spreadsheet is
yes,
still very useful, and so is mechanized thinking that we call
yes.
AI. Sorry, you were saying?
So what I was saying is that as I was saying about a artificial intelligence, the broad spectrum which captures the imagination of people is more about artificial general intelligence, where like a
Right.
human being, we are
AGI. Yeah.
very, yeah, AGI is what people think about when they think about artificial intelligence.
Artificial
But
generalized intelligence. Yeah.
yes. And AGI would mean that somebody, an intelligence which can create a music piece as much as a piece of art, as
Right.
much as it can solve complex mathematical problems
Right.
and explore the wonders of space. That is the kind of intelligence when it comes to open thinking about what a common person would think about
Right.
artificial intelligence,
Right.
which is like a human but a superhuman. So you can actually access the stars at the same time and depth of the sea at the same time, and make a connection
Right.
correlation between the two. That
So
is what.
when we get to AGI, it will
Yes.
be able to do all those things. It will be able to do great art, great music, do computation, all that sort of thing. Now we are finding in the news that some of those features are being done. For example, even now, AI can recognize cancers in an X-ray better than humans can, and can often find prospects in a database better than humans can, because it's much faster. Just like a spreadsheet's a lot faster.
Absolutely.
But
Absolutely.
we haven't got an AGI yet. We won't have one for another 10, 20 years. But in the meantime, we've still got these, I call them modules. I don't know what you call them. But I'm very interested in hear what we can do with these modules. If we're not going for AGI that bundles all the modules together to be a genius, what have we got? What modules have we got? What can we do?
In the technical term, is artificial narrow intelligences.
Okay.
So artificial narrow intelligence, what it does is basically it focuses on one task and it does better than probably a human cognitive capability.
Okay.
So for example, let us talk about the cancer detection algorithm.
Okay.
We're talking about that humans can look at the scans of, the X-ray scans, the CT scans, and other scans that our doctor would do in the past.
Yeah.
And it can look at and it can apply its, humans, when they would do it, they would basically apply their intuition, they would apply their gut as well as their training to actually come up and detect cancers.
Right.
What artificial narrow intelligence in this case is able to do is able to replicate this, because it has learned through multiple sets of thousands of data set which has been passed through it, and it's been able to, in a supervised learning perspective, so the doctor has basically said, yes, it is a cancerous, growth, versus this is not a cancerous growth. And so multiple doctors over thousands of places, and they are looking at what the artificial intelligence is coming up with, and they're saying yes. So every time it gets a yes or a no, it tweaks itself and it learns better. So now it has come to a stage where it can do better. It can, from an individual doctor.
So it's working from a lot more examples than any human can. It can be sent to race off around thousands or even millions of X-rays and make the rules just as our own brain can. We are the part of our brain that recognizes a cat or a dog or an X-ray that's got cancer in it. That's just because, like a child, we've been exposed time and time again, and we start to get the idea of what the rules are. If it's round, if it's this color, if it's shaped like that, if it doesn't move, then that's how we build these rules with our own so-called neural nets. And what you're doing is you're replacing those, or the AI is doing, is simply replacing one of the functions of our brain. Not the whole brain, but a very useful part of it. And it's outdoing us because it can be exposed to a lot more data a lot faster.
Yeah, absolutely. And that's just one example, and maybe one of the more extreme examples of what we are doing. In fact, people are trying to apply the same pattern of thinking, the pattern recognition and the neural networks, are being applied for solving variety of problems to do with the vision, to do with the speech, to do with learning of, what is happening. By repeating the same task, you're learning better. So, and then there is another aspect of it which has come through. One is where you think about it like this: when you are training a little child, what you do is you tell the child, look, this is a bird. This is a bird, and this is a bird. And the kid starts repeating, yeah, this is a bird. That's how it learns.
Right.
What the other way is that the kid is walking beside you, and you are talking to your wife and you say, look, it's a bird. And another time you go around and say, look, it's a bird. And kid is just observing. You're not telling anything to the kid. You're basically telling, look, it's a bird. Look, it's a bird. Look, it's a bird.
Yeah.
And then the kid recognizes it itself and then starts saying, this looks like a bird.
Now, what the kid has done, it has, every time the parents have done that, it said, okay, it's the kid's brain. This is not conscious on the kid. But the kid notices that the thing they call a bird has got two extensions on the sides that wave, and it's up in the air. It's not on the ground usually, and it may make certain kinds of source. So the kid's brain starts to pick up that is a habit of that thing. A thing you call a bird, it's got these characteristics. This one, that one, that one, that one. They're all got wings. They've all got up in the air, so it makes rules. So that is pattern recognition. A thing that flutters, makes sounds, is up in the air, likely to be one of those things called a bird. Right.
Maybe it has made all of those connections, but let's say it sees then a plane. And then when it sees a plane, the kid says a bird. Now, to a human, it'll say, no, that's not a bird, it's a plane.
And the kid says, why?
And a kid asks why. The problem with the machine is that machine is not able to ask why. What machine is saying is, every time you are seeing and pointing out to a plane, it will learn that it's a plane, and it will be able to differentiate between what's a bird and what's a plane based upon the number of times it has been talked about.
Right.
but it cannot ask the question, okay, why is it not a bird and why is it a plane? And 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 that is the key difference between the way we are training these models, what we call as supervised learning and unsupervised learning,
Mm-hmm.
deep learning. These are kind of
Right.
concepts that when you just do a simple Google search, you'll come
Yeah,
across
yeah,
all
yeah.
of
Okay.
these concepts. It's
Okay.
not very difficult to understand, but I'm trying to explain it in a term how
Okay.
you would teach. Think of AI, or whatever we are calling it is, whatever this machine learning capability
Yeah.
is also about how you train a young child.
Yeah.
And from an infant, how do you train him? You train
Yeah.
him through, the kid learns through instruction. So
Right.
you would basically give him the instruction that
Yeah.
this is what you need to do, this is what you need to do,
Okay.
this is what it is, this is what it is,
Okay.
and it learns.
So you've got pattern recognition mechanisms in the brain, and you've got pattern
Yes,
recognitions, the same sort of thing. They're just generalized like algebra. Pardon me saying that, but
yes,
they're generalized, and
yeah,
the AI may not know why you corrected it and said no, that's not a bird, but it has got sort of eyes or visual ability, and it will make a
yes,
note and say that was a plane, and it will look for differences in its rules and say, well, I've noticed one difference: the plane's wings do not flap.
yes,
So if from now on, if I see a bird whose wings do not flap and it
mm,
makes that kind of noise, then I'm going to
yes,
call that a plane until I'm told otherwise. So it's
otherwise,
got pattern
absolutely,
recognition. So that's visual pattern recognition. It also may be sound as well, because the
yes,
bird makes certain kind of sound. And if the AI has got sound abilities as well for its rule making, then it will say, okay, I can hear the sound is different, I can see the wings are different, therefore I'm starting to learn. So these are built-in, manufactured, mechanical features of AI inside it that enable it to learn as it goes along.
absolutely, absolutely. So that's the core concept about how how we have gone about.
Right.
And in the 80s, you can talk about, Bruce, a little bit about how the 80s, it was already always instruction led.
Oh,
The
yeah,
need
yeah.
for
When I created an
input
expert system,
inside of it.
we wrote the rules. We didn't. There were neural nets around then, and I wasn't doing those. Well, we just wrote the rules. One of the expert systems I built, it had 500 rules in it, and every one of those rules, I got a friend of mine who was my employer he was a psychiatrist and he was diagnosing depression. I had to learn all that stuff and make it a tree of decisions that would determine whether or not the patient was clinically depressed and what treatment they should have. So it was totally mechanical, but it didn't have a lot of smarts in it. It could just respond to question, it would ask question, get an answer, and so on. Quite right. But now we're
Yes,
building in much more smarts in the so-called neural nets, those rule-making
yes. And actually, we flipped
features.
the model around. So we flipped the model around. Earlier, it was you had inputs, you had a function, and
Yeah,
then you had the outputs.
right,
What you are now looking at is you are basically pushing in the inputs,
right.
and you are basically classifying the outputs, and then the function is being determined by the machine itself.
Yeah, well, this is
This
really what interests me. I want to know what can be done these days. You're the modern man. I want to
Yes,
know what your company and you can do for
yes.
me,
So
especially as a private individual as well as a business, if there's anything that can be done.
yes, so we are. I'll come to what
Okay,
we can do, but let me just first talk about what AI is capable of at this point of time. So
okay,
the way we were talking about the learning and the neural networks and the stuff that we just talked about, what I'll take a little bit of a detour and to explain what are the neural network, because this is a term which a lot of people understand and want to know about, and
okay.
then when you Google it, you basically come across a lot of mathematics around it and a lot of coding and programming around it. Neural networks are the way in which the humans, understand stuff. It is like when a stimulus is given to the humans, what happens is that as Bruce said earlier, it could be audio input, it could be a video input, it could be a text input, and all combined coming together. So now when we see it, or sense it, perceive it through our eyes, ears, and it goes into a head, then what happens is there is different parts of our brain which get fired based upon it. So the colors fire it differently, the sound fire it differently, the mixture and patterns fire it differently, and those images and those sounds, they get correlated and they get recorded in it. Now, when we are able, so these some of these stimulus we are able to capture, and some of these stimulus you are able to, identify, because there is a labeled way of saying it. So, as I said in the previous example of looking at a bird, when the parent tells you that this is a bird and this is a bird, that word association starts happening
Right.
with you. The
Yep.
next time when you're looking at a bird, you're able to picture a bird even when you're not seeing a bird at this point of time. So that is the kind of pattern recognition bit that is happening. But there are, when you go through your dreams, there are things which are happening in your dreams which we are not able to classify, or things which are odd, which have no classification so far, which humans have come across.
Right.
Then those are images which are imprinted on your brain, but you cannot recollect them, you cannot call them, because there is no explanation.
So there is no label for those things. There may
Yes.
be in your brain a visual, non-verbal label for them,
Absolutely.
but
Absolutely.
there's not a label that the parent has told you or some friend has told you.
Yes.
That's interesting. Okay.
That is how that is, but that is still getting recorded. Now bring it similarly into the machine world.
Yeah.
We do exactly the same thing. We are exposing it to, let's say, very commonly when you are writing emails on Gmail.
Yeah.
You are writing in a particular way. If you are writing in English, you say hello. My name is such, and you're introducing yourself. My name is Sudiip Mathur, and I work for Genisys Robotics.
Yeah.
So then, this is kind of a pattern that it is recognizing. If Bruce is doing it, he would be doing something similar. He would be writing. He will be introducing himself. Hello, it may be different from hi or dear sir, but he would basically still say, and that's a pattern. And when you look at millions of these, you are able to say, okay, my name is. Right. Then it will prompt whoever is the name in it. It will automatically prompt that name, because that's how everybody puts it.
Okay, so name is a so-called concept.
Yes.
It is the seed of a network.
Yes.
Name has connotations. It's a label with connections going out and branching from name. Name has all sorts of connections, right?
Yes. Well, the point I was making is that when you are passing this through an algorithm which is actually looking for patterns, what it does is that it recognizes that every time somebody is typing my name is, the next prompt would be the account holder's name. In most cases.
All right. Okay. So so you didn't even have to tell it there was such a thing as name. It just saw name and it says, "Oh, I see that everywhere. So I'm going to make a label called name. I'm going to watch for it. I'm going to see what connections it has with other things."
Yes, absolutely. And that is how it is predicting that when you are typing today, if you go into Gmail and you are typing ahead, it is basically able to predict what you would be putting in next, and it makes your life easy.
Right. So it doesn't have to be told. So we've made the point to the audience that these, I call them neural nets. Do you still call them neural nets?
Yeah, these are still called neural nets.
So these so-called neural nets are a built-in generalized kind of software that can pick up the drift without you having to label things specifically. It will notice repetition of something and the connections of that thing and say, "Oh, I've discovered something. It's called a dog. It's got 4 legs, it barks," and so on. So it can pick up these things without having to be told, because it has got rule-making ability. Now, the next thing I'm dying to find out from you, Sudeep, is what modules have you and Genisys got? You've got visual perception, rule-making neural nets. You've got audio ones. You've got text ones. What have you got? How many modules, different modules have you got?
Let me bring it out a little bit. It may be a shocker to a lot of people.
Okay.
But we've gone about talking about this entire thing in a very, very technical way. We've gone about talking about it in a very mathematical way, neural networks and other things. And we may have lost half the audience in the discussion about neural networks.
Okay.
Let's talk about what is the capability behind it.
Yeah.
So the capability that you're talking about is recognizing a dog, recognizing a bird.
Yeah.
That is the capability that you want to do. What you want to do with that, if I detect a dog, the next thing I want to detect is the tail is wagging or the tail is down, because that would give us a sense of whether it's going to attack or whether it's going to come play with us.
Right. Okay. So you're saying that the AI today can not only discover there's a thing called a dog and know that it wags its tail, but it can start getting other rules too, like the wagging of the tail tends to be when it's about to be fed or when it's happy or when its master comes home. So it's making all sorts of very useful deductions about a dog. And for example, if it wasn't a dog, it could be a burglar, it could be a person walking onto my property. So I could, if the AI watched lots of people come onto lots of properties, it could say, well, the ones that do this and this and this tend to be called burglars or
Mm.
intruders. So that could be useful, couldn't it?
Yes, it could be definitely useful. So, and that is where we are trying to build it in a fashion where a common person understands. So we don't want you to understand as much of the neural network and the coding.
The technology. You just want to know what it can do. Yeah, we've sort of explained
Exactly,
that. Right, right,
exactly, and
right, right.
that is where the difference. That's why we are calling it a next generation of AI.
Okay.
There are the capabilities are very vast, and people who are building it are doing at a very large scale.
Yeah,
But one of the challenges that people face is that when you are actually exposing it to a lot of data, and from if you say we pass through million images of all the animals,
yeah,
and then it's able to detect a dog, a cat, and everything,
yeah.
you are not really sure what it is doing. So then, in one of the examples which we learned from neural networks, there was a training which was being done for white wolves, and white wolves. The neural net was shown a lot of images of white wolves,
Okay.
and when it started to recognize and when it started to look at, because we could not tell it that it is a white wolf that we want to train on, what it detected was it started recognizing ice instead of white wolf,
Okay.
because white wolves were always found in ice background.
And
All
some
the
some
photographs that
ice
it,
would look like white wolves.
yes, yes. So what? So whenever they would want to push in a photograph of white wolves, it would basically, and if the photograph did not have ice, it would
Okay.
not pick it
Okay.
up as a white
Okay.
wolf.
Yeah, yeah.
And if it had ice but not a white wolf, it would still classify it as
Right.
a white
By
wolf.
the way, folks, this is just demonstrates how dumb AI can be.
Yes, absolutely, absolutely. And that is where the question, this is where the challenge becomes, is that when you are relying on AI to make all the deductions, and you're not able to explain to AI why it is making those deductions, where it needs to change, and you have to do a lot of preparation of your data and a lot of pipelining of your data, cleaning of your data to actually force it into that model and train it and tweak it. It takes money, it takes
Right.
energy, it takes time, and if
Right.
it doesn't deliver the output, then suddenly the companies who are actually
Right.
trying to make money off it,
Right. Right.
they can actually go bust.
Right.
So therefore, the adoption of AI at a mass scale, there are tens, believe me, there are tens of thousands of AI startups which are out there, and every man and his dog is basically saying we are powered by AI. And I don't mean it and I do not mean it in a derogatory way, but I'm
Yeah. Yeah.
basically
Yeah.
talking about
Sure.
everybody saying we are powered by AI.
Yeah.
It's more like, going back 100 years back, when the appliances were becoming, electrical appliances were becoming, electricity was becoming more common. Everybody would say it's powered by electricity.
Yeah.
It's
Right.
now
Right.
saying powered
Yeah.
by
Yeah. Okay.
AI. In few years' time, you would not even call it AI.
Okay.
Think about a future where everything is connected with sensors, and there's an IoT world, where everything is basically connected to each other, and the decisions are happening not by your actions, but by connections and the signals that are being
Yeah.
received from.
IoT stands for Internet of Things. That's everything from your toaster to your shoes have got sensors in them reporting information into the cloud. That's what he meant.
Yes, absolutely. Thanks, Bruce, for clarification for the audience. And when you are actually looking at this information coming in, so this information will be coming in volumes that human brain cannot comprehend. It could be at the same time your door outside your house, your refrigerator, your shoes, your spectacles,
Your heart rate.
everything that
Yeah.
you're
Everything.
actually
Yeah.
having,
Yeah.
wherever you can imagine,
Right.
is sending this information
Right.
across, and it is being processed. So now, when it's processed and there's actions which are being taken on your behalf based upon your patterns of how you deal with those things. So if the milk is less in your refrigerator, what
Yeah.
you do is you order milk. So it doesn't need you to come in and say you need to order
That's
milk.
that's
The milk
very good. That's very good,
order.
Sudi. But one thing, our audience will be alarmed by that because they'll think, I don't want AI to take over my life. I want to be in charge of my life. I want to determine how much milk there is in the fridge. I don't want the thing snooping in my fridge. So we're going to have to sell the idea of AI being under our control and
Yes.
benefiting us. All right?
Absolutely. But this is where why we are departing from the current world, which the big six are pushing around our way. It is basically saying we'll ease your life, but you will have to give up your privacy, which
Mm-hmm.
is basically what food do you have in your in your FA.
Yeah.
I was talking to a certain gentleman who had a very intelligent, very interesting idea. I'm
Yeah.
not sure I'm allowed to discuss it, because it's under confidentiality. But what they were talking about is using your sanitary waste,
Okay. Yeah. Yeah.
and detecting stuff from the sanitary waste. What is the kind of problems you could have? What are the problems that your child could be having?
Yeah.
What are the kind of stuff that you'd be having? And then providing you solutions proactively. Now it can really solve your life. I completely agree that if you are able to tell that an infection is developing at early stages because
Yeah.
you have those residual samples,
Okay,
it's
so
also
the urine and feces is being examined medically to very, very early detect cancer cells and other signals where you
yes,
can intervene so early that you just don't get cancer, you don't get the disease. That's what he meant.
absolutely. But then, are you willing to allow your humble toilet roll to be actually connected to a third party who's basically sending out this information that you may be
Yeah.
actually having early problems? And
Yeah,
that
well,
is where the
yeah,
line comes.
that's right. I mean, some people will say, no way, I'm not going to allow that. But I think most people are going to say, I don't want breast cancer, I don't want bowel cancer, so I'll choose it. So I think
Yes.
most people will go with that, but it'll be a choice. It won't be forced on you. I mean,
it, it-
it
that is exactly, this is
right,
where the choice part is coming in, that
right.
are we actually getting that choice? Are we actually, if somebody comes and says, here are all these sanitary products which we are distributing for free, and you take it, and this is where what is happening,
Yeah,
this whole freemium model is basically
yeah,
corrupting the whole thing as well, is that you're giving stuff away for free,
right,
and in return we're not even realizing that we are, and because we're getting stuff for free, we're
right.
very easily signing
Okay.
off that end user license
Okay,
agreement.
okay. So in that case, it could be the government, the city council and the central government are saying, we will offer this service free to anyone, and the reason we're offering it free, out of taxpayers' money, by the way, is because
Mm-hmm.
we've got a huge medical bill every
Yes.
year, and we want to reduce cancer and Alzheimer's and all those sorts of things. So
Yes.
those who want to, we will pay for them to have this monitoring of their waste so that we can arrest their sickness before it gets serious, and that will be an option for them. All right. So AI can do that kind of thing. But Sudeep, what I want to find out is, apart from these things that will be done for us by the state and by companies and so on,
Yes.
I'm curious about which of the modules of AI, like visual
Yes.
or hearing or text and so on, which of those are available online now for me
Yes.
or anyone to actually actively go in and start using? Can I do that? What can I do? Especially ones that are simple enough for an ordinary human being, somebody who knows how to do spreadsheets or use a computer. Is there any, are we at, what stage are we at regarding those modules? I know the vision one, the sound one, the text one, whatever. What can be done now without having to be very clever?
So let me say that all that you are talking about is available in open source domain by a lot of companies, including the Googles of the world.
Okay.
Google has made the TensorFlow entire framework available to people for free. And you can do all those capabilities, vision, sound, everything is available for free.
So all right, then could I build, if I get a camera put on the front of my house,
No.
I
My short answer is no.
okay.
My answer is no is because you need to know the technical capabilities and the coding capabilities to be able to access this code, host it on a platform, on a cloud, on a server, and then you will be able to then, even if it is drag and drop, the machine Microsoft is
Yeah,
offering
yeah,
a
okay.
drag and drop
Okay.
service,
Okay.
but you still need to deploy it and you need to be a coder or programmer. So you, as a normal human being, will need to understand first of all the terminology. So we're not talking about detecting a dog, we're talking about image classification.
Yeah, yeah, yeah. See, you know what I want. I want something that detects a burglar. It can tell it from a friend. In fact, have you got face recognition modules?
Yes.
All right.
Yes,
So
I can show you some stuff which we are doing. That can you allow me to
yeah, yeah,
share
sure,
my
sure, sure, sure. Okay. Share screen. Hang on a second. Screen one. Oh, hang on. It's share enable. Is it? Share computer. Optimize screen. Advanced. Hang on a second. It's not letting me. Just hang on a second. I've just got to go to share screen. The options is allow. Multiple participants. One. Here we are. All right. So that should enable you to share now.
Yes, let me just see if I
While you're
get.
doing that, I'll talk to the audience. What I'm trying to get him to do is enable me to do fairly straightforward things, or even pay someone not a lot of money to set it up for me. For example, if I wanted to be able to detect burglars on approaching my house, or things like that, personal things in my life. I'll think of other ones later, but you know what I mean. Something that can be done to benefit me in my personal life, and also could I get it to look at a whole lot of my email and say, these are the people you should contact about joining that group, that kind of stuff. I want to look at direct, useful applications for me. All right, where are you, Sudiip?
Let me show you what is possible in the art of possible, and
Okay.
how we do it.
Okay.
But let me show you what is possible. So
Okay.
if you are able to see what the video is of a CCTV footage
Yeah.
on in front of us. So what we
Okay.
want to do, we want to analyze this video feed,
Okay.
and this is what you can actually do. So if I may pause for a second,
Yeah.
this video. So
Yeah.
this is a CCTV camera. You can
Yeah.
connect this feed live, and we've got a module which will basically analyze the people who are entering in.
Okay.
We're talking about age,
Yep.
gender. Sometimes we can actually look at what is the kind of expression that they have,
Yep.
what is the kind of thing.
Yep.
But broadly, we are able to detect who's coming in, what is the profile of the people who are coming in into
Yep.
our
Yep.
into our
Right.
and what we can do with it. Let's just see what we can do with it. So we are getting this information.
Yeah.
What do we do with this information? So this is great. This is great for surveillance, and this is where the people are actually a little bit scared about what people can do. But
Yeah.
let's see what we are doing with it. What we are saying is, this is coming in.
Yeah.
Now what we are doing is real-time customization of digital displays. So when you are, think about yourself, and I'll before I play the video again, think
Okay.
about that you are in a mall, and there are digital displays which are already installed in the mall.
Okay.
What you are seeing right now is a standard display. So McDonald's has done some advertising, Samsung has done some advertising, Apple has done some advertising, and it is there.
Yeah.
It doesn't talk to you, it doesn't speak to you, it does not attract your eye because you are not interested in it.
Right. Okay.
Now imagine that this is a feed that you're getting, and you have this digital display.
Yep.
And you are walking to it, and then based upon the person who's walking around, it gets
The reaction. It's getting the reaction.
getting the reaction. It is not
Okay.
based upon an individual who's walking, but it is based upon the kind of people who are walking in.
The
So, for
profile.
example,
It's the profile of the person. So then you know whether that advert works or does not work for those people.
Exactly. It's more targeted.
Okay.
It's more likely that it will catch the eye of the people. So let's
Okay.
say the way we are actually looking at is, let's say we are talking about a mall in which the time is about at 12 o'clock in the afternoon.
Yep.
And you see a rush of people who
Yep.
are wearing ties and who
Yep.
are in their mid 20s to mid 40s
Yep.
who are walking in.
Yep. Yep.
It's lunchtime.
Yep.
It is people who are coming in.
Yep.
So rather than showing a display about Samsung Galaxy phone,
Yeah.
if you were to actually show a McDonald's,
Food one to do with food. Yeah.
absolutely at that point of time,
Right.
there is higher chances
Yeah.
of that leading to a conversion.
Yeah.
Because people may or may not be interested in the Samsung phone at that point of time. They will be
Okay.
more interested in what is the best deal that is
Okay.
available to them.
Right.
And those are kind of decisions which can be made very easily based upon using some of this.
Yeah, well, I mean, that one is so obvious. You could be laughed at for using AI to determine whether around lunchtime people are more interested in food.
I agree.
The first example was where you saw the age groups that were interested in a particular product, and you say, well, I didn't realize that 13 to 15-year-olds were quite keen on that Samsung phone. I didn't think they'd be interested. So it can be a very good detective of that without, by the way, intruding on people's privacy. And we can talk about the security issues. People expect in a mall to be under a surveillance camera anyway, so I guess the privacy problem isn't so serious. But when you are using it this way, the main thing people would be concerned about is whether ID of the individual is being used.
No, so that is where we there are two key things that we do.
Yeah.
One is that the video never leaves the premises of the CCTV camera.
Okay.
So if you are in the mall, the video will never leave from there.
All right, hang on. Could I set this up with a cell phone downtown? Let's say I'm a musician, and I play guitar and downtown on a Saturday afternoon, and I set up a cell phone connected to your cloud-based app, and I can tell which people like which song the most, so that I can play the songs the people like most, judging from their behavior. Could I do that? I mean, I do get some.
Possible. It is definitely possible. It is basically noticing reactions of people who are actually coming through. So
what would it cost me to do that?
Well, it is not going to be cheap for you at this point of time.
Okay.
Why it is not going to be cheap is that because the cost of hosting it, on the cloud and analyzing it at this point of time, it is less for individuals and more for corporates at this point of time. Because still we are able to democratize it. But let me tell you how easy it is to build it. I'm not talking about. So one is the solution that we build and we deploy for you, which is going to be because we are doing it. But let me show you how we actually go about building it and what we are doing in it. I think that will give you an idea of how we can actually look at. Let's say this is what we have. If you see my screen, this is what we have is what we call as a Flow AI Studio, and this is what we have is what you have as workflows. Now, when I talk about workflows, let me see if I can create a simple workflow for you. Let me say create a new workflow, and I'll say sample workflow. And here we've got these applications. Now these applications, as you see, there are some of them are over here, some of them are not yet here.
But by the way, these are what I was calling modules before. Are some of them visual, some of them text, some of them sound? What are they?
So there are different. So some of these which are already available on our platform are built to custom, for our customers. But they are, for example, you want to have a data transfer. So you are actually getting this information from, let's say you're getting this information pulled into the cloud. So this is where your CCTV feed is basically feeding into a cloud, or the information that you're detecting, you're feeding into a cloud. You've got this information, you connect it very simply by putting in the details of your cloud bucket. And from there, you basically look at things like image classification. So let's say we've got one for.
Now, does the user do this, or do you do this?
So we currently it is with us. But how we're just going to show you. Let me talk to you about a case that we built for one of our users, which was for detecting the car damage, which you have. So suppose your car meets with an accident and your insurance company has to come back to you to say whether its car needs to be written off or whether it needs to be repaired and how much it's going to cost you to repair it. That process takes almost 3 weeks in most part of the world to actually get it done. And the way we are able to do it is very simply, let me start with a workflow which we already have. And if you look at this workflow, and I'll show you very quickly how easy it is to create this workflow. So this is where from your mobile app, if you take the pictures of your damage and you basically send a message to the car insurance company that your car has met with an accident, that information goes into a bucket on Amazon Cloud. From there, we're basically picking up the images. So we are looking at all the images and we're looking at, is there a car part in there? Ones which have a car part over here.
So it can recognize what kind of car you've got and which fender or which part of it is damaged. It can look at it and say that.
Absolutely. So but we are doing it in small parts. So we're not doing a big bucket of things. We're not saying it will give you an answer. We're basically saying this part is an image classification algorithm behind it, which will basically look at all the images and detect only those parts which have got a car part. If it doesn't have a car part, they will be filtered out. It will filter out only the car part.
So it's not doing all of them, but it's doing a very useful proportion of the cars. It may fail and say, sorry, human, you've got to do it. But in a lot of cases, it can say, I can do this, and go right through the whole process.
Absolutely. And from there, from detecting a car part, the next step that a human would do is we do it intuitively, but in sequence, if you look at it, we would basically look at, is this damaged, not damaged? And you would say, this is a damage detection or not. At the same time, when you're looking at a car part, you want to detect, what car make it is, what car model it is.
Okay.
You've got a car make detection model, which
Okay.
is basically bumper images inside it,
Yep.
which would basically be able to say, okay, this is an Audi, this particular model
Okay.
from this particular year, so that you are then able to look at the cost of write-off,
Okay.
for that particular
Now,
model.
in that car damage detection, it was judging how damaged that part or that car was.
No, it is just classifying those parts which are damaged or not damaged. So if
Okay.
the
Okay.
fender
Okay.
is damaged but your bonnet is not
Okay.
damaged,
Okay.
then it will basically classify
Okay.
that this is damaged.
Okay. Okay.
There's a next step, from even if you think about from a human cognition point of
Yep.
view,
Yep.
this is the way you would follow it. You would basically look at the severity of it,
Yep.
and you would say, okay, how long does it, is it badly damaged? Is it
Right.
lightly damaged?
Yep.
Or it's okay,
Yep.
it's just a surface
Yep.
job.
Yep.
And then once you've got this classification of severity, what you then look for is damage repair estimation. So look at whether this part needs to be replaced, then what is the part of the cost of the part, what is the cost of the labor.
Yep.
And you can actually have a live feed which is coming in from the suppliers.
Yep.
Who would basically be able to do this estimate based
Okay.
on this. You'll be able.
Yep.
And you push this information back to the and to build it, as I was showing you earlier, it is as simple as dragging and dropping stuff. So
Okay.
you can actually delete this, and all you need to do is to connect this, and from the downloaded files all you need to drag is car images.
Okay.
So now-
So what you're saying is you're putting this together out of ready-made modules.
Yes.
Right. Okay.
Yes, ready-made modules, but these are micro modules. We are not talking about solving the whole problem for you.
No.
in
No.
one
No.
go.
No. Okay. Okay.
Yeah, these are all micro modules. These are all powered by your AI technologies, whether you call it computer vision, whether you call it text to speech, whether you call
Yeah.
it natural language processing.
Okay.
It's all powered by these. But notice the label. If you notice the label on each of these,
Yeah.
there is no technicality in it. This says you can create this workflow yourself without the need of any understanding of AI. It is how
Okay.
human
So
would solve this
so
problem.
this could be detecting the burglar on my property if I wanted to.
And
Yeah.
if you are able to classify and write down the steps, if you had to identify a burglar,
yeah.
so let us say you would want to put in,
Right.
that the burglar may have a face covering. So you might want to say
Right.
detect face covering.
Now, hold on. Now, if I wanted to do this, let's say that I looked around on the internet and rang up police stations and everything, like rang up police forces,
Yes.
and they said, "Sorry, buddy, we just don't have that stuff, or we're not going to give it to you."
Yeah.
You could provide me with something that would work from my camera, or
Yes.
it would access YouTube videos by the thousand of
Yes.
burglaries and stuff like that, and would pick up what a burglar was and how they behaved.
Yes, it can be done. It can be done.
Okay.
The question would be, and this is where we need to be a little bit more. We go 2 steps forward.
Okay.
Rather than we trying to detect a burglar, we
Yeah.
try to break it down into smaller parts, and we look at what are the kind of characteristics that you would need to identify a burglar. And some of these would be common. Let's say burglar may not be, but from a person detection perspective
Yeah.
and the access perspective, how the people are trying to access it, there could be modules. And this is where we are going and reaching out to the open source community, where people are already
Yeah.
building a lot of this stuff.
Right.
We're not talking about building everything for you. What we
Right.
have is called a user app section.
So you
And
have a library of possible modules that could help in this case.
Absolutely. And what we are actually reaching out and what we are building right now is called a machine learning app factory. This
Okay.
app factory is basically going to expand the breadth of the kind of capabilities that you can do. Our aim is not to go technical at all. We want it to be customized in a manner in which a common person can understand, so that
Yeah.
you can drag and drop.
Right.
So image classification would have multiple implementations. One of them would be, I said, document, driving license classifier.
Yeah.
You could actually have a claims document classifier.
Yeah.
It is still a classification algorithm.
Yeah.
But we are making it contextual for you.
Right.
And we are driven by use cases,
Right.
so that you are able to build it yourself, is what we are trying to go for.
Okay, so you would find for me the building blocks that I could use to create my own burglar detection system.
Absolutely. And where the benefit that we see in this entire thing is, it's very understandable for anybody who does not have any kind of technical knowledge.
Right.
They understand the business
Yeah.
process or the process that they want to
Yeah.
solve.
Yeah.
We may have the application, we may
Yeah.
have some of these
Right. Right.
applications,
Okay. Okay.
but we can easily identify the gaps in where we don't have it,
Yeah. Yeah.
and
Okay.
then we can scout the
Okay.
internet to find out it for you or build it for you.
Yeah. Okay.
But that, because of reusability of components, it is much faster, it is much cheaper, and it is much more explainable to somebody who is basically going to deploy these solutions.
Right. Right. See, I'm getting this, to summarize, I'm getting the impression, Sudeep, that this is more at the moment a commercial application than a personal application. I mean, I'd love to have this kind of thing, just drag and drop modules to look at all my emails, for example, and pick out the people that I should be talking to more about that, or people who might be able to help me with this health problem or whatever it is. I mean, I'm really quite keen to have that sort of ability, because I know what AI can do, just as you've described.
Our aim is to get there very quickly.
Right.
Our aim is to get there very quickly, but
Okay.
we need, at the moment, we are self-funded. We have in limited
Yeah.
funds where we are actually
Right.
utilizing it to
Yeah.
provide it at scale to people. This is
Yeah.
a B2B thing, is much more easier because
right.
I have a paying customer.
Yeah, yeah.
But
So your car damage detection thing, how much faster, just by the way, you didn't tell the audience how much faster it is to do it.
Okay, so
For the
let
ones
me
that
just show
work,
you.
what percentage of cases does it successfully solve just like that?
Yes. So let me just show you my screen again, because that would be rather than me telling you.
Yeah.
This is the one. Yeah. So if you look at the dashboard, and this is where we look at, we have a dashboard where we can actually see how fast it can do.
Okay.
This is the workflow that we talked about.
Yeah.
Motor damage estimation.
Yep.
And let's not go for the best one, but let's say on an average, it takes about 7 minutes, 31 seconds
Yep.
to actually run this entire job, detect what car parts are damaged.
From a
estimate-
photograph. That's from one photograph of the car?
Sorry?
What is it working on? Has it got one photograph of the car? What has it got?
No, it's got multiple. So it's got multiple. So the photographs, we basically told them the photographs of all the damage, wherever you think that the damage is, you've taken all the photographs. It's
How
working
many
off-
photographs did I have to take?
They have to take about 8 photographs.
Okay.
8 photographs, that is an average that we recommend. So one is of the boot, car boot, which basically helps us identify the car.
Does the user take those photos?
Yes, the user is taking those photographs.
Okay. Yep. Right. So I've done it with their cell phone. They've gone snap, snap,
Yes,
8
down
times.
with their cell phone.
Yep. Okay.
Down with their cell phone.
Okay.
Now, in 60% of cases, what we are able to do is, in 30 minutes time, the insurance company is able to go back to the customer and say, so we are able to solve it in 7 minutes, but we are basically relying on the insurance company to have 4 eyes check on it,
Okay.
rather than taking our view.
Yeah.
We give a kind of confidence interval up to how confident we feel about this particular outcome.
Yep.
With each of these,
Yep.
so that the insurance company can say, in 60% of cases, they're able to go back straight away and say, this is how much it's going to cost you. What
Yep.
happens with that is they are able to improve their customer satisfaction. What they're able to do is they don't have to pay for a courtesy car. So if 3 weeks, if you're paying for courtesy car, it's a cost out of your bottom line straight away.
Yep.
So that cost is reduced.
Yep.
You can straight away direct, if your car is a write-off, you can straight away direct the person to the next, the nearest garage where you can actually buy a new car.
Yep.
As an insurance company will pay for it.
Yep.
So you're always mobile. The customer satisfaction increases.
Yep.
And you have a secondary ecosystem of people, companies which would want to buy in to say, okay, if you come off a write-off case, how can we actually position our companies to sell the next car to this particular individual?
Yeah. Hang on, you just said 3 weeks. So you're saying it was about half an hour. Within an hour, you could do what normally would take a process of 3 weeks to do.
Yes, absolutely.
And 60% of the cases.
In 60% of cases. In 20% of cases, what happens is that the images may not be rightly taken,
Okay.
or documents may not be scanned correctly, or your images are probably against a light source or something.
Okay. So you fix that. Now you've got 8 good photographs again. You've got 60% of those 20%. So what's your total with a redo? What percentage of cases are dealt with within the hour?
So when we are dealing with the second set of cases, we are not dealing it in an hour. We are basically taking out a week, so that we give the user a time to actually update those photographs. If they don't have a driving license, correctly validated, or there's something which is if they don't have access to documentation, we give them a week to do it rather than we do it immediately. And the 20% of cases, it is very clear that surface damage will not be sufficient. We detect from the surface that there is more internal damage, and the estimation cannot be done from surface. So in that case, you will have to send a surveyor in, and that will still take you. But if you look at the kind of cost that it has taken away for 60% of the cases, it is, and the kind of benefit that it's provided, it makes all the more sense for people to actually work with it.
Now, all right, could you hazard a guess of what the payoff time? Let's say that I'm a who's it saving money? It's saving the insurance company money. It's saving the customer money. Can you give an idea of how long it takes to pay itself off? Who bought this? Did the insurance company buy it? Who bought it?
Company. This is the insurance company who's going to buy it.
How long did it take them to pay it off? How long does it take them?
So the ROI is 12x is what we are looking at.
Return on investment is 12 times.
12 times, and over 3-year period, we are looking at the kind of benefits that you're going to get. The sample size of the company is 2 million. They have 2 million customers. From our analysis, basically, you have 2 million people who are basically insured with you. 1% of those people are actually claiming for damages and using our application. And those, basically, if you're looking at deploying it, you're looking at about 12x return on investment over 3 years' time.
Okay, but what's that? How long does it? What's the payback?
So payback is depending upon again. I wouldn't hazard a guess, but we have up to 3 to 4 months you can actually get back. So it takes 3 months to deploy the solution for you, train it on your systems, because each country has. So even though I can detect a car part is a car part anywhere across the world, but if I have to detect what car part, every country has a different cars.
So anyway, so what you've said is it gives 12 times what it cost me. If I'm an insurance company, it's given me 12 times what I paid for it to be built. Within 3 years.
Within 3 years.
And can I ask what it might cost? Does it depend on the size of the insurance company? What sort of cost?
It does depend upon the size of insurance, but our average ticket sizes are in the range of $100,000 US dollars. So it starts from around 50,000 for a simple use case, but for a complex use case like this, we're looking at 100,000 to 500,000 USD. That's why I said that it's not in the realm of individual, because there is
it's still very exciting. I mean, how many doors have you knocked on in the insurance industry now?
We have been knocking the doors on the insurance industry.
How are they reacting to it? We haven't got a lot of time now, but it's
So they are currently, so in a couple of cases we have employed this, and they are currently running in a parallel run. So right now nobody wants to make a switch over immediately to real time. They are seeing the benefits of it, but they want to be sure of the technology before they actually adopt it.
How long have they been using it now?
So 3 months, and our agreement was for 6 months now.
And how are they feeling? So they've been using it for 3 months. So they've got a pretty good idea now. Is it obeying what you thought it would obey? In other words, is it performing as well as you thought, as well as we saw there?
Yes, it is. In fact, it is performing better than what we thought.
Okay. So they must be very happy with that.
We found one of the key things that we found is that most of the accident claims are for bumper damages. So people backing out their car and backing it back in. So those are very straightforward ones. There's nothing. There are complex crashes when you actually have multiple cars coming in together. Those are difficult ones, but most of the things are, you would scrape your car against a particular curve, or you would basically scrape your car backing out, and that's where it's much easier, because it's very straightforward as to what needs to be done.
Can I ask you, how much have they paid? How much are they going to end up paying? Let's assume they're happy. So they've presumably given you some money now. I don't know whether you're able to say that, but they must have given you a deposit, because other insurance companies may be watching this. What deposit did you ask for, and how much in the end, when you say goodbye, here it is, we'll help you, but basically you're going to pay that?
So we are giving this solution as a hosted solution on a virtual private cloud for them. The whole idea is that you don't stay stuck into one workflow that we have created for you. This is another problem with the AI industry, is that you create a static solution or static model which doesn't
Sure.
So we are offering this workbench on a subscription basis.
Is that based on a percentage of their benefit, or what is it based on?
So it's not, we're not linking it to benefits at this point of time. We're not as big at this point of time to link it to their benefits yet.
Well, how much a month are they paying then?
So at the moment, the run rate is about $15,000 a month is what they will need to pay. Sorry, $15,000 a year, not month. Sorry.
So it's $15K a year, and how much are they making? If it's 12 15s, that's 180,000.
Yes. So this is the number that I told you is for the subscription of the license. We basically charge them an initial fees for building up this workflow.
Yep.
And then they are leveraging it. So on a run rate basis, they will be paying me $15,000 to be able to build their own models on this tool and deploy those own models.
Yeah. Okay. Hang on. So they're paying $15K a month. How much are they benefiting net after they've paid you the $15K? How much are they making per month?
They are making at least 3 times. They're saving at least 3 times what they're getting for.
Okay. So let's say they pay you $20K, and the benefit is $60K. So they're still making $40K a month.
Yeah, I can give you an example of how it is
that's
working
fine.
out.
That's fine. I'm just getting the idea. Okay, so that's pretty good. Now we haven't got a lot of time. This is fascinating to me because we're getting the quantities here, and I think other insurance companies would be interested in this. I'm curious also about the step aside to the next thing, because you've done cars, and they say we love you. The car system is great. What are they going to ask for next? Injuries?
Yes, so we have so not with injuries, but we've got for medical. If you in certain parts of the world, you are where it is self-paid healthcare. So we look at insurance claims which are coming from. There's a lot of documentation which goes with it. Medical prescriptions. You've got invoices from for all if you are actually coming out of.
So this is all text-based, mostly text-based.
Yes.
Okay. So you're doing the same sort of thing, but instead of doing an image that somebody's taking photographs, you're looking at the data, you're doing optical character recognition, you're saying that person has got a tibia and fibula both broken, it's going to cost $20K, etc., etc. They're not on medication, they're retired so they don't have to pay salary, etc., etc. So it's doing all this tech stuff, and it's coming. How fast is it coming up? Have you got one working? Of this?
Yes, we've got this one working as well, but this is yet to be deployed. So we are in agreement to actually deploy it for our customers.
Okay.
We're signing up for it. Okay. But it's not yet deployed in the fleet.
Okay. Can you give an idea? I realize you may not know this, but can you give a similar estimation or comparison between the cost per month this will be and the benefit per month that will arise? Because in the car one, it was about $20K a month they'd have to pay, but they were getting $40K of profit, net profit off it every month. Would you say the similar thing would apply in medical, or different, or more or less? What?
Medical, we have seen that we have had discussions and ROI discussions across different countries. So we've had discussions in India, we've had discussions in the US, and we've had discussions in the UK as well. The key difference is how some of these things are priced are very different in India. Because in India, you are actually self-paying most of it, and insurance covers part of it. Whereas in the US, everything is covered by the insurance. The pricing of the stuff is all by the insurance companies. And the prices of all the medication and all the prescription and everything is matched up to those. And in the UK, it's all paid by the NHS. So the kind of quantum of benefits in terms of money is very different if you are looking at India versus UK versus.
But all things considered, whether you're the NHS in the UK or you're a private insurance company in UK or a private insurance company in the USA, would you guess that the benefit per, you'd pay, let's say you're paying per $20K a month that you pay, would you say you are going to get $40K of net benefit, or more or less, if you were guessing?
I will not hazard a guess at this point of time. What I can tell you is that in terms of the number of cases and the speed at which you are able to do it, that is where we are going to make a biggest impact. And whether it's how that speed translates into money for you is something that needs to be estimated on a case-to-case basis.
Okay. Thank you, Sudiip. We're nearly finished here. It's been very valuable talk. I think the viewers will have got the idea from the insurance company and the automobiles and talk about the hospital applications. You can see the potential of this stuff. I'm a little disappointed that I can't yet use it with my own keyboard from home, because I like that potential to apply it to my email or to my invoices, you know, the bills that I'm paying. I'd love that kind of ability, but it's very exciting to see this in your company. So I wish you well in your company's operations, and it's been wonderful talking to you. Anyone watching this, put comments below, ask questions. Sudeep's available there, and you can talk to Genisys Robotics if you'd like to do something with them. All right, so we'll finish it off now. Sudeep, thanks again.
Thank you very much, Bruce. It was wonderful talking to you.
Bye.
Yeah. Bye.